Alrighty, so this is problem number 4 in your electric math packet that looks like this. We are going to be working on example 4, which is on the back of the second page right here. So the first thing that you need to do is draw the circuit. So I'll give you guys a little bit of time to draw this circuit. The important thing to remember about this circuit is that it's parallel. So it's a parallel circuit, so that means the current doesn't flow in one path. It flows in many paths. So we have 6 volts. That's our potential difference. At our first path, path 1, our resistance is 1 ohms. Path 2 is 2 ohms. And path 3 is 3 ohms. So remember that the voltage is going to be the same across each path. So on each path we're going to have 6 volts. Now what does change is the current. Remember that current, the electrons want to take the easiest path possible. They don't want to go 3 ohms when they can do 1. So more electrons are going to go through the 1 ohms than the 3 ohms. So in order to get the total resistance, that's our goal, total resistance, we need to look at the total current. We need to find the total current that is running here and here. So the way we do that is we have to find the current going through path 1, the current going through path 2, and the current going through path 3. So we break it up into 3 paths. So let's do the path 1 first. Now we're using the same triangle still. We're still using V on top, I, and R on bottom. So this is our triangle that we're going to be using. So for path 1, we'll make a chart. So, the voltage for path 1, we're going to write down our given. For path 1, our voltage is 6 volts. For path 2, it's 6 volts. For path 3, it's 6 volts. Remember that the potential difference is the same throughout all the paths. 2, 3, then our total. So for all of the paths, including our total, our voltage, our potential difference is 6 volts. So you can write that 6 volts throughout your whole entire board. Here's our final unknown. Now we also don't know the current through the total. So that's what we're working towards. So the first thing, breaking into paths. Remember, path 1 has a potential difference of 6 volts and the resistance is 1 ohm. So we set up our triangle. We put 6 on top, 1 on bottom. We have our unknown. So there's the first triangle. 6 divided by 1 is 6. So our current on path 1 is 6 amps. Next, let's look at path 2. So our current on path 1 is 6 amps. Now we're looking at path 2. Our resistance on path 2 is 2 ohms. Our voltage is 6. So we can plug in R. We have 2 ohms. Now we can plug it into the triangle again with 6 volts on top. Our I's are unknown, and our resistance is 2 ohms. So our I equals 6 volts divided by 2 ohms equals 6 divided by 2. Plug that into your calculator. You should be able to do this in your head. It is 3 amps. So, path 2, 3 amps. So now we got to look at path 3. We're almost there. Path 2 is 3 amps. So we can plug in 3 amps right here. Now we got to find path 3. So what it's saying is that as the electrons go this way, they have 6 amps. Right here, alrighty, so my battery just died. So we'll try this again. Sorry. So, I believe we are on path 3. So let's calculate the current for path 3. Again, I apologize if I was in the middle of something and it left off. Battery died. So, with path 3, our voltage is still 6. Our current is our unknown. We do not know that yet. And our resistance is 3 ohms. So we plug it into our triangle. 6 volts goes on top, 3 ohms goes on bottom. Our current is unknown, so our I equals 6 volts divided by 3 ohms, and we get 2 amps. 6 divided by 3 is 2. So that is our path 3 current. Now let's go back to our diagram. Figure out what this means. So if our current on path 3 is 2, our current right here, before it breaks into any of the paths, the total, that's our total current. So we have 6 plus 3 plus 2. That is going to be our total current. So we have 6 plus 3 plus 2 amps. So our total is going to be 11 amps. So we have 11 amps going. Then we have our first break. Now at this break, 6 amps are going to be going through path 1, while the other 5 are going to be going through path 2 and 3. We have 5 amps here. Then we get to our second break, fork in the road. 3 amps are going to go path 2, while the remaining 2 amps go through path 3. So when they all come back together, we have 11 amps. So there's our total current. So our total current is 11 amps, and we just added 6 plus 3 plus 2 equals 11. So now we're at the final part of the problem. What is the total resistance for this current? What is for this circuit? So we're going to use the same triangle with our voltage, our potential difference being 6, our current being 11 amps, and our resistance is unknown. So we'll have 6 volts on top, and on the bottom we will have our I, that's our our I is 11, and our R is our unknown. So we will do R equals 6 volts divided by 11 amps. 6 divided by 11, plug it into your calculator, equals 0.54 amps. So the total resistance for this circuit is very, very small.